Here is an adjustable auto on-off delay timer circuit using 555 IC. And I'm Agna Dimanale.
And my group members are Glenda PV, Lakshmi AB, and Nancy Paul.
Timers were used in many applications in our day-to-day life. One can see timers in almost all the AC appliances that we use. Time delay circuit can provide a simple, reliable, and economic control when a definite purpose solution is required. Providing time delayed switching to start a motor, to control a load or affect a process. These are typically used in industrial applications. Additionally, they play an important role for targeted logic needs, such as small panel or in sub-panels. They had a variety of features and operating characteristics such as compatibility, economy, simplicity, and ease of use. An adjustable auto on-off delay timer circuit using 555 IC is a simple circuit that automatically turns on or off any output during or after a fixed predefined duration. For example, you can turn off a mobile charger after, let's say, 1 hour to prevent overcharging the battery. The time delay can be fixed to time periods like 1, 5, 10 minutes, etc., or for a duration ranging from a few seconds to hours. And the time period for this circuit that we have been made can be found out by using the formula T is equal to 1.1 into R into C, where R and C are the values of time delayed in resistors and capacitors. For further explanation, I move on to Nancy.
Thank you, Agna. Now I will familiarize you with the components we have used for this circuit. So the components we have used are a 555 IC, 470 microfarad capacitor, resistors as per the timings, and a potentiometer, and 5 to 12 volts power supply. And here in this circuit we have connected an LED as the output device, but if you want to connect an AC device, you can connect a relay module with it. So now we will move on to the working model of our project. This is the working model of our project. By this circuit you can turn on or off any DC appliances. If you want to turn on or off any AC appliances, you can club it with a relay module. So now I will familiarize the components we have used. So this is the 555 IC, and this is the capacitor which starts charging when this push button switch is pressed, and this is the resistance, and this is the potentiometer. By this potentiometer we can adjust the time. So this is the red LED which will be turned on when this push button switch is pressed. So from here we are obtaining output, and here we can connect any output devices instead of this LED. So when we connect voltage to this circuit, the green LED will be turned on. It indicates that the circuit is working, and it indicates the timer is off. And when we press this switch, the red LED will be turned on, and it will be turned off after a fixed duration. So here we have set it for 4 seconds. So it will be turned off after 4 seconds. So when we press it, it will be turned off in 4 seconds. Yes, it is turned off after 4 seconds. So we can adjust the timings by turning the knob of the potentiometer. Now I will set it for 10 seconds. Oh my god. So now when we press this push button switch, it will be turned off after 10 seconds. So this is how the circuit works. It is a simple model. For changing the duration, or for long duration, you can adjust the values of capacitor and resistance, and you can adjust it from seconds to hours. So this is now I will explain the circuit connections. So for the connections, we know that for a 555 IC, it has total 8 pins, and the first pin is grounded, and the fourth and eighth pin is connected to the voltage, and sixth pin, which is threshold pin, and seventh pin, which is discharge pin, they are connected using a jumper wire, And the third pin of the 555 IC is the output pin, which is connected to the positive terminal of the LED, and the negative terminal of the LED is connected to the ground via a 22 ohm resistor, and the voltage is given to the push button switch via a 10k resistance value, and the negative terminal of the capacitor is grounded, and the positive terminal is connected to the 6th and 7th pin of the 555 IC, and it is connected to the resistance we have used to calculate, that is 68 kilo ohm resistance, and is connected to the voltage. So these all are the connections. So now I will hand over the session to Lakshmi. Thank you.
Thank you, Nancy. Now I am going to explain the working of the circuit. Before that, I am going to explain how a 555 IC works. It is a 8-pin IC which works in 3 different modes: monostable mode, stable mode and diastable mode. Most of the timer ICs works in monostable mode, and there is an inbuilt voltage dividing system within the IC, and this voltage controlling system is controlled by with the help of 2 other resistors. After the first voltage division, there will be a 2 by 3 volt exist in that IC. After the second voltage division process occurs, the 2 by 3rd voltage is lowered to 1 by 3 voltage. The function of the trigger pin is to detect whether the voltage is less than 1 by 3 occur or not. Similarly, the working process of a threshold pin is to check whether the voltage is exceed than 2 by 3 or not. And another characteristic of the 555 IC is that the ground pin is connected to discharge pin within the IC. So this is a small working principle and procedure of a 555 IC. So let's go through the working of the circuit. Consider the switch is in off condition. So the 68k resistor and will have a 68k resistor and the VCC is in low state. As a result of this, the capacitor couldn't manage to charge. When we press the switch, or if the switch is in high state, the trigger pin will detect this high voltage, and it will check whether this voltage is lowered to 1 by 3 or not. If it is lesser than 1 by 3, automatically it will give a high input. As a result of this, the LED will close. So the function of the threshold pin and the discharging pin is controlled by the trigger pin, and when the threshold pin is activated, automatically the VCC will activated. As a result of this, the capacitor starts charging. When this charging is exceeded 2 by 3 volt, this increase, sudden change or this increase will be detected by the threshold pin. As a result of this, the threshold pin will suppress the output and it gives a zero output. As a result of this, the LED will be stop blinking. The discharging time of this capacitor is used to find the timing of the circuit. So this is a short description about this project. Now I am handovering the session for Glenda.
Thank you, Lakshmi. I am here to introduce about the various applications by using this auto-adjustable delay timer circuit. This adjustable delay timer circuit using 555 IC that can automatically turn on or off any output after a fixed duration. The electronic timer circuit is helpful when you need to power on or off any AC appliances after a predefined duration. For example, you can use this circuit to automatically turn on or off a mobile charger after, let's say, 1 hour to prevent overcharging the battery. The 555 IC timer can produce very accurate and stable time delays from microseconds to hours. It can be used with supply voltage varying from 5 to 18 voltage. The timer delay can be fixed to time periods like 1, 5, 10 minutes, etc. It can be used in cooler controllers, irritation pump control, exhaust fan switching, industrial repetition switching, and load shedding and control automatic lubrication tools, traffic light controls, printing applications, etc. and also used to control heavy loads such as AC appliances or DC motors. Using this circuit, you need to add a relay module on the output of the circuit. Expressing our sincere gratitude to our HOD Rajiv sir for giving such a wonderful opportunity for improving our technical knowledge. Thank you.